Hey guys, in this video, we'll talk about how to adjust mining difficulty. First, we need to figure out what is mining difficulty. Every proof of work protocol defines a block time, an interval within which a new block should be created. Or we can explain it this way. When a miner solves a block, he broadcasts it to the network immediately, and the time this miner took to mine this block is block time. And a blockchain needs its block time to be basically stable, which means the average block time needs to be around a fixed number. That's the reason to adjust mining difficulty, to make block time consistent. Why blockchain needs a consistent block time? We will not talk about this issue in this video. We only focus on mining difficulty adjustment. But all we need to know is basically it's for blockchain's security. So some blocks might be solved quicker and some block might take a bit longer. But in average, they are near to block time. Of course, in different blockchain application, block time is different. In Bitcoin blockchain, block time is 10 minutes, which means a new block will be generated every 10 minutes. So mining difficulty is adjusted every 2016 blocks, which is every 2 weeks. Because one block takes 10 minutes and 2016 takes 2016 times 10 and it's 14 days. In Litecoin, it's 2.5 minutes. In Digibyte, it's 15 seconds and it's adjusted in real time, which means it's adjusted every time a new block is mined. So now we're clear that mining difficulty adjustment means make block time consistent. What are reasons that impact block time? How to make block time consistent? In How Mining Works video, we talk about that blockchain produce new blocks through mining. Mining is a process that add a nonce to the block header and bundle up all the information inside the block header with this nonce, put them into SHA-256 together, then get a hash. And this hash cannot be greater than our target value. So the mining process is to find the nonce, and a nonce can be found only by brute force search, which means the only way is to try every possible nonce one by one. Let's say if during mining one node can only try one possible nonce, the real situation is every node can try nonce very fast. A miner can try like million possibility once, but let's assume one node only try one nonce every time. Then 10 nodes can try 10 nonce at the same time, because nodes can work together. So along with the blockchain nodes getting more, the speed of trying get faster. The amount of node impact mining speed directly. And the total computation power of all active nodes is called hash power or hash rate. Then it's obvious, if nodes get more, then the mining speed gets higher and the block time gets shorter. So that's the real situation. It actually happens to every active blockchain. Nodes are getting more and more. So if we don't adjust mining difficulty, the block time will get shorter and shorter. Now let's see how to adjust. So we say mining is to get a nonce smaller than or equal to target. Target is a number we need to get below to mine a block. It's obvious that this target is very important for mining. But how does this target impact mining? Now let's imagine this situation. Let's say the target is infinite. Then no matter what hash we got will be smaller than the target, right? We already know the hash produced by SHA-256 is totally random. The hash could be very big or it could be very small. But in this case, it doesn't matter because the target is infinite. So no matter what nonce we put into block header, the hash is always smaller than the target. So immediately mining is done and we got a new block. So now we can get a conclusion that the value of target can impact the difficulty of mining. Let's see this figure here, how it works. So the range of SHA-256 is from 0 to here. And the range of target is from 0 to its maximum. No matter what nonce is, the hash value get by nonce and the black header will always be in this range from 0 to this blue line. So this maximum target for proof of work is set by Satoshi Nakamoto in Bitcoin. It's hard-coded. Of course, in different blockchain it can be different, but mechanism is the same. So let's observe this figure. We can see the bigger the range of target is, the easier the hash meets the requirement, which is lower than this red line. If the target is infinite, the hash is always lower than it, right? So the target is smaller, the probability we get a hash lower than this line is smaller. Or we can say mining difficulty is harder. That's how mining difficulty is adjusted. If block time is too long, we set target bigger to make it easier to get below the target. If block time is too short, we set target smaller. We adjust downwards to make it more difficult to get below the target for the next period of blocks. These are some parts of Bitcoin target history in 2010 and 2012. We all know that as time goes by, Bitcoin is getting more and more popular these years, and its target history definitely shows that. You can see the target value is getting smaller and smaller than before, which means mining difficulty is much harder along with the more nodes join the Bitcoin network. Now let's do the math to see how exactly we adjust mining difficulty. This is how Bitcoin calculates its mining difficulty. And different blockchains might show you different ways to calculate in their white papers, but they're basically the same. So let's check this as an example. Block time is calculated by this equation, and our goal is to make block time stay at 10 minutes long. So in this equation, this is fixed, and hash rate is the number of hashes miner calculates per second. Hash rate is changing in real time, and difficulty level is changed every 2016 blocks. So how do we adjust this? First, block time is fixed, and the blockchain network can get its own hash rate very easily in real time, because apparently it knows how many miners it has. So every 2016 blocks, a blockchain will use its current hash rate and block time, which is a fixed number he wants, to calculate a different difficulty level, which is a number. And we know the maximum target is fixed, which is the number we mentioned before. Then we have difficulty level and we have the maximum target. We can get a current target we need. This target will be used as a target for the mining of next 2016 blocks. But miners join and leave the network over time. So this hash rate keeps changing before next adjustments. And that's why the block time will not equal to exact 10 minutes, but it's near in average. And that's how we adjust mining difficulty. Thanks for watching. See you on the next one.